Okay, good morning everyone. Just calm down, it's normal. Good morning everyone. Okay, so what I'm going to do is, good morning everyone. All right, welcome to VINDAL'S Academy. And today we have this question on machine, screw jack questions. So this is the diagram of the screw jack. So it's just like that you use for lifting lifting a car when it's broken down and when it breaks down. So this is called a tummy bar. Most of the times, people don't know what the tummy bar is. That place you hold and turn. Sometimes some people do it like this. You understand? And they keep on. So something is going to increase to carry your car. So this is where the load is dropped. While this is the thread. This thing you are seeing is thread. You know, sometimes you are trying to loosen something. You are tightening it. So this is the thread. So there's something we call pitch. Pitch. That pitch is the distance between the threads, one thread to another thread. The distance separating them is called pitch. For small knots, remember screw and jack, we are only also talking about screw, bolt and nut, and anything you can loosen. Some of the screw are too small, some are big, like those particular nut or bolt that carry bigger objects. They are going to be big as well. So now the question said a screw jack is used to raise a body of mass. See, the mass is very, very heavy, like a car. Now, through a height of 0.25 meter, that means it's lifted above the ground. By turning its tummy bar through 30 revolutions, if the length of the tummy bar is 0.75 meters and the jack is 75% efficient, calculate its velocity ratio. All right. There is something we call velocity ratio. Velocity ratio is defined as what? Distance moved by effort over distance moved by load. All right. So, let's all say velocity ratio is what? Distance moved by what? Effort all over what? Distance moved by load. Why mechanical advantage, though it's not asked, but I know we need it, is given as what? Load over what? Effort. Now, one thing I want you to know is this. Load can be expressed in Newton. Look at the load here. It's given as what? Mass, kilogram. But I can also express it to be in what? In Newton. By doing what? Multiplying it by 10. So I will express it as weight. So if I multiply it by 10, I'm going to have 60,000 Newton. I can also express effort to be in Newton as well. Do you understand? So that's what we are going to do. Now, velocity ratio for a screw jack is different from velocity ratio of an inclined plane. Velocity ratio of different machines are different and they have different formula. But this is the general formula for all all velocity ratios. For example, if it's an inclined plane, we're going to say that velocity ratio is what? 1 over sine theta. You see? Different machine gives you what? Different velocity ratios. Now look at what happened. But for this one, for a jack or a screw jack, velocity ratio is given as 2 pi r over p. Are you with me now? What is r? What? The what? The radius. You say radius, you say tummy bar. However, it's not bad to be radius, but it is the length of the tummy bar. See it from here to here. In fact, this handle, the length of the handle is usually referred to as tummy bar. Some questions will look at it as that. So, but if you check the question, if the length of the tummy bar is what? Look up. This is the question. This is the radius, the r there. So, but pi is also given as what? 3.14. So I'm going to have 2 times 3.14 times what? 0. What? But look at what it says. It goes through what? Come on. Do you know what that means? See, for something to go through once, it is what? 2 pi r. That is a circumference. From here, you go back here. 1 revolution. But he did it in what? 30 times. So I'm going to multiply by 30. Because 1 revolution times 30. All divided by what? Pitch. What is the pitch? The distance between the successive what? Threads. Okay, so what is the pitch there? Were we given the pitch? Can you tell me the pitch? What is the value of the pitch? Wait. I think 1 revolution. I think this pitch is going to be the revolution. You understand? Because for it to go from one to another one, because remember, as I'm turning, this thing will be moving up. For you to move from one to this one pitch has gone. I think it should be that revolution. So let me confirm. X. No, I'm correct. Times 30 is correct. But please let me pause the video. Let me confirm something. Okay, so the pitch, I'm going to assume that the pitch is 0.25 because remember, for every revolution it moves a little. For every revolution it goes a little up, right? So the height through a height of 0.25 is going to be the pitch. So I'm going to say 0.25. So let's do this. This times this times this. You say is one what? 141. 141.3 divided by 0.25. So velocity ratio is what? 56.2. There is no unit for this, right? So keep it. So that is the velocity ratio. Now we have found the velocity ratio. So that is the first one. Second one is the effort required to raise the load. I cannot find effort when I don't know the mechanical advantage. So what should I do first? I'm going to find mechanical advantage. Then I can find the effort. But I cannot also find that apart from going through this formula called what? Efficiency. What is efficiency? Mechanical what? Over velocity ratio. That's correct. Times what? 100% all over 1. So efficiency there is what? It's always expressed in percentage. Whenever you see percentage, you know it's efficiency, right? So I'm going to have 85 over what? 100 equal to mechanical advantage. Is it given? No, right? Are we giving effort? We are not giving. Okay, no. I have I don't know mechanical advantage, but I have velocity ratio, which is what? 565.2. I'm now going to multiply by 100. Look up, because I've already I'm dividing it there. If I don't divide it there, that means I'm multiplying it here. So let's go. I'm going to say that mechanical advantage is going to be what? This times 85 divided by 100. 85 times 565.2 divided by 100. What's the answer? 4 what? 480.42. Everything. Okay. So there is no also unit. There is no unit. So I have found my mechanical advantage. I can now find what? Effort. So effort. So we say that mechanical advantage is what? Load over what? Effort. Now I'm going to express them in Newton. I like to express in Newton. So load is what? This is the load. So I'm going to multiply by 10 to express it in force, in weight, which is going to be 60,000, right? Divide by what? E, which is effort. Now this is going to be 480.42 is equal to 60,000 all over what? Effort. So effort is what? 60,000 divided by what? Divided by 480.42. What's the answer? 8 point what? 8.007 times 10 raised to the power minus 3. All right. That means, see, Effort is too small to lift a load of 60,000, which means the machine, the screw, the jack is very, very good. Because you don't need to put too much effort to lift a very heavy mass like this. So your effort must be very small. You have a very small effort. That means that is why it's what? A machine that helps you where you put small effort to carry a large load. Thank you very much for being part of it. Also remember to hit the subscribe button, like and so. What is your question?
In the formula for efficiency, you didn't times it by 100.
Times what?
Mechanical advantage and over velocity ratio.
In this formula, I didn't times. Okay, times 100. Yes, I was explaining. If I'm dividing it by 100, I don't need to times it here. Remember, I'm supposed to, if I remove this 100 here, then that is where I can times here. All right? Do you understand what I'm saying? So, but because I don't times here, it is here. No problem. Do you understand? Any question? You say?
What of if the efficiency is not given?
What if the efficiency is not given? For them to give us anything for us to solve, they must give us, there must be one they did not give us and ask us to find another. For example, I have efficiency, I have mechanical advantage and velocity ratio. These are three things. It's either they give me these two and say I should find efficiency, or they give me these two and ask me to find mechanical advantage, or they give me these two and ask me to find velocity ratio. So they must give me two out of the three and ask me to find the other. Are you going? Oh, comma, are you going? No, I'm there. Okay. So thank you very much.
You said you were changing everything to new. So why not do 480.40 times 10?
My mind is off. You said what? Please, okay. Off it.